All right, guys, so continuing on in 5.2, we have to look at different kinds of asymptotes. We looked at vertical asymptotes already, and those happen whenever we had a value that was not in the domain. Now we're going to take a look at some other kind of asymptotes. And for the other asymptotes, the vertical ones are always when the numbers are not in the domain. So you look at the denominator and we solve for 0 and all that. Now we're going to look at other kind of asymptotes. Remember, in the reciprocal function, we had the horizontal asymptote. And so we're going to kind of see how the horizontal asymptote works. Okay, so it works like this. Let's say we had a function like this: f of x equals 6x plus 2 over 4x squared minus 9. So we can go crazy and we can go ahead and figure out what the vertical asymptotes here are, and that's cool. But right now I want to focus on the horizontal asymptote. And here's how it works. So we look at horizontal asymptotes, we look at the degree of the numerator and the degree of the denominator. Okay? And here's how it works. If the degree of the numerator is less than the degree of the denominator, then something always happens. Okay, so the degree of numerator is less than degree of denominator. I'm lots of abbreviations here. So degree of numerator less than degree of denominator. That's what we have here. Degree up here is 1, degree down here is 2. Remember the exponent. So we have that situation. If that happens, then we have a horizontal asymptote at y equals 0. That's how that works. At y equals 0. No matter what else is happening, all right, if the degree of the numerator is less than the degree of the denominator, we always have a horizontal asymptote at y equals 0. Okay, and you can kind of see that in the reciprocal function. If we pull this back again, in the reciprocal function, the degree up here is 0, degree down here is 1. So the degree of the numerator is less than the degree of the denominator, so we have a horizontal asymptote at y equals 0. All right, so that's the first piece of it. Next scenario, let's do f of x equals, let's do 3x squared plus 9 over 5x cubed, or 5x squared, sorry, 5x squared plus 2x minus 4, all right? In this scenario, we look at the degrees again. Here we have the degree of the numerator is the same as the degree of the denominator. So degree of numerator is equal to degree of denominator. When that happens, now this is the one that I'm always not very good at saying in words, and the book is not very good at saying in its words either. But let me just show you what it is. In this particular case, there will be a horizontal asymptote, and it will be at the line y equals 3/5. Anybody see where it came from? Right here, 3, 5. All right. We look at the leading terms of each one of the numerator and the denominator, and here's a 3. This is called the leading coefficient, the number in the leading term. This is 3. This is 5. We put 3 over 5, and that's what the horizontal asymptote is going to be at. Okay. And so I have a hard time saying that in words. The way the book will say it is it says it like this: is it says if you have ax to the n over bx to the n, so same degree, and these are our leading coefficients, then you have a horizontal asymptote at a over b. So that's the way that the book says it, to kind of generalize that. So I guess this might be the best way to say it, probably like this. We'll just plug that in here, and that's how we'll say it. So if the degree of the numerator is equal to the degree of the denominator, then we follow this rule. All right, we do the leading coefficients, the fraction caused by the leading coefficients. That is where the horizontal asymptote is going to go. Okay, that's how that works. Now, let's go ahead and for the last one, let's do a new video for this one because it might take a little bit of time, all right?